Okay, so we're going to talk about the PhySens application and how to install it, how to use it, and the benefits of using it. Before we get into that, I wanted to just show the type of output that the solution can provide. This is actually from a previous run I did, and I'll show you it running in real time in a moment, but I wanted to just capture this and show it to you. This is a run where I'm capturing the SCDE values and the temperature, and of course I was doing it in real time. And on this particular tag that I had selected, I had mimicked a water leak. So I had a few drops of water that had fallen onto the backing of a sensor tag. And you can see here that the SCDE value changed about 7 minutes in when I dropped the water onto the material, and the tag immediately picked it up. And you can see the SCD value fell to whatever it is, 120 versus 240, so basically halved right there with a few drops. We can see the temperature changed very slightly. It's probably just a second order effect, or maybe the water was just slightly below room temperature. But interestingly, you can see that the SCDE value does start to increase again. So that tells us this was a temporary leak and started to dry out pretty much straight away. And this was heading back towards where it was originally. And then I did another leak where I actually dropped hot water onto the back of the material. And again, we picked up the moisture on the material straight away. The SCDE value dropped. But this time also the temperature rapidly increased and jumped all the way up to 60, just over 60 centigrade. And then that started to increase slightly and then started to decrease as the temperature went down as the water cooled down. And as the material also started to dry up as well, in this case a little bit more slowly than previously. And at some point in the future event, I actually kind of just dried off the material a little bit really quickly. Not completely, it wasn't quite up to the original value, but you can see it very quickly dried up here and the value of the SCDE value increased. And I basically brought the material down to pretty much to room temperature in doing so as well. And then towards the end of here, I just kind of I ended the experiment and moved the tag around a little bit. But that gives you an idea of the type of graph that can be produced real time by the PhySens application. Okay, so next I'll give you a few tips just to kind of be helpful. First of all, we're using one of the SensRay family readers, which has an internal antenna. This happens to be a SensRay Enterprise, but it could be a SensRay Pro, SensRay Core, or any of the other family members. The tags will look either something like this or like some of these. I tend to advise customers to not put the tags directly onto the antenna here. There are nulls and you can get slightly inaccurate readings if you're very close to the antenna. So tip number one, find a handy book. Well, ideally read it from about a couple of feet away, but if you can't do that, get a handy thick book, and then we can use that to put the tags on. And it gives you a little bit of separation and a little bit of additional material between the antenna and the tags. The other tip I have, tip number two, is rather than just play with the tags and their form like this, I tend to like to put them on a piece of thick paper or card. And the reason for that is it becomes pretty easy to make them wet. And so you can actually see their behavior as you put some water on them and the water soaks into the paper, and you can see the drying out over a period of time. If you just use the raw tags, it's just a little bit more difficult to get water on them, basically, and it's a bit more messy. So that's tip number two. Okay, so the first thing we're going to want to do is to download the PhySens application. which can be downloaded from the SensThys website. And once you're at our website, you'll want to go to support and then software. Under software, you'll see our software development kits, the applications which we're interested in, and firmware. So click on applications and you'll see PhySens for physical under the applications. Just go ahead and download that. You'll see that is a zip file. So let's go to, you can move the zip file to wherever you want it, wherever you want to run the application from, and obviously just go ahead and extract it. And then what I tend to do is I kind of like the idea of getting the PhySens application and basically just creating a shortcut onto my desktop, and then you've always got it handy. And that's basically what you need to do to get the PhySens application installed. Okay, let's go ahead now and run the PhySens application. As soon as you run the application, you'll probably see the reader populate automatically. Readers put out a heartbeat on the network, which the software will identify. So the first thing to do is to click on the particular reader you want to use and select the antenna that you want to read from. In this case, I'm just using the internal antenna on the reader I have here, so I'm set up fine. You can read either temperature or SEDE, which is the register measurement of the environment the tag's in, or both. So I'm going to show both in this case. You also want to select the tag type. We're continuing to expand the different types of tags the software interrogates. I know these are Magnus S3 based devices, so I'm going to go ahead and select Magnus S3. You probably don't want to change these values. I think the default is 28 maximum, 14 minimum, or somewhere around there. I wouldn't worry about changing those. You may or may not see the sample period here. Our sample period is set to 2 minutes by default. If you really want to change that, you can right-hand click on the area right where you see the sample period here, and it may not be visible, but you right-hand click, and then it will give you the option of popping this up, and then you'll see this this little extra piece of information, this extra dialog box here. You then have the option to save the data to a file. For sample period, I wouldn't normally use less than 20-30 seconds. I'm going to use less than that just for demonstration purposes. It's not quite as accurate at a shorter period of time, but I just want to show pretty quickly how this works and some of the interaction when you get these wet. So I'm going to go ahead and go to measure now. So what this is going to do is it's going to give you some information here about how much time it's going to take to the next sample. In this case, I selected 5 seconds, so it's going to be pretty quick. But if you were selecting 2 or 3 minutes or 5 minutes, this bar would fill up over a period of 3 to 5 minutes, depending on your period. So at least it gives you some visual indication of how frequently the measurement's going to be taken. So this tool can be used to take measurements over an extended period of time, an hour, 5 hours, 6 hours, 24 hours, a couple of days, if you want to actually monitor something over a fairly lengthy period of time. The read duration, you can set this to however long you want to measure for. This is in seconds. I can do it for 3,600 seconds. If you leave it at 0, it'll just carry on reading until you tell it to stop. And then just go ahead and let's start reading. So it immediately populates with all the tags it sees. And you saw initially there that it wasn't providing any data. It just saw the tags and filled that in a list here. And then in this case, in 5 seconds, it's going to update the information being interrogated from the tags. So that's the temperature, and that's the SCDE value. And these are going to be plotted in real time on the screen I'm going to show you next. To get to that screen, you want to select a tag and then go to graph. And then you can see in real time the temperature and the SCDE value being measured. I can go back and I can go and interrogate another one. And again, here I can see the tags being interrogated in real time, this particular tag being interrogated in real time. So what I'm going to do now, I have a little handy bit of water. This is why I like doing this on card, a little bit less messy. And I'm just going to make back of that a little bit wet. And we can immediately see that's being detected, and we're starting to see this drop pretty dramatically. And so this particular tag has reacted to the fact that there's moisture now present in its environment. And obviously I've got it pretty wet. Just another tip, the actual measurement area of the tag where the measurement is actually taken is right around the center where the chip is in the tag. So we can actually see it's reacted a little bit to the fact I've picked the tag up. But you can see, it reacts that quickly, and obviously we now get a nice visualization of what's going on in the environment. So finally, just to give you a little kind of look ahead of what's coming. So I've demonstrated to you here the reading of temperature and the SCDE, which translates to both moisture, but also some other physical attributes inside materials. But I wasn't able to demonstrate it today, but we're also going to be adding very shortly the ability to measure strain of the material. So literally physical strain, stretch, or bend of material that the appropriate tag's embedded in. So lots of exciting stuff coming, and certainly we'll be using the same tool. So you recommend go ahead, get it installed, start playing with these tags so you can have some real fun with it. And if you have any questions, please reach out to us. We'll be happy to answer for you.